let us start the topic that is called as metallurgy. So metallurgy means how metals are extracted from minerals. So we are starting here with a concept that is mineral, ore, something like that we are first discussing, and then various processes. Say for example, if I am talking about mineral is any say chemical, usually in form of sulfide, oxide, chloride, bromide, iodide, something like that, which is obtained from nature. We are getting deposits of these minerals. Sometimes, say for example, sodium chloride, that means our common salt. So we can obtain it from sea. So that is also accompanied by a little bit amount of magnesium chloride. Now you are aware when we are having limestone, it is calcium carbonate. So like that, various minerals are available in nature. Now some minerals are used to extract substances, they are not considered as metals. But some minerals, they are used to extract substances, they are considered as metal. Now if from mineral, metal is commercially extracted, here the important word is commercially. So on commercial term, if we are able to extract metal from mineral, then that mineral is called as ore, O-R-E. So ore is a mineral, but need not be every mineral should be ore. Now here we can consider various ores, but again question is that why metal is to be extracted? Because metal, can we obtain metal in the pure form? Answer, yes. Certain metals we can obtain in pure form. Let us check. Out of that first metal, obviously, famous Indian metal, that is gold, which is obtained in naturally. We are getting gold lumps, and so we can get gold directly from nature, no need of ore. Whereas gold is very less reactive. We can categorize under noble metal, so one can get gold. In certain parts of world, we are getting iron or nickel in the metallic, pure metallic form. How? Most probably we believe that that is a site of meteorite fall. When these asteroids, they are wandering in the space, they are faced to sun in the space. Because of solar winds and solar radiation, it gets heated to very high temperature. Whereas all bonds at that time can break out, particularly chemical bonds, they are breaking out. Now if, say for example, if gold is in form of its oxide, then obviously oxygen is a gas which can go out and pure metal can be formed. So usually whenever these meteorites are there, at that time we may get, not always, but we may get pure metals like nickel or iron if they are present in the meteorite. But otherwise, what happened that Earth with fewer sites, some sites like we are aware of Atacama Desert, that is in South America. Like that, certain sites are there where rainfall is not at all observed and climate is extremely dry. So forget of that site, but other than that, everywhere we are having humidity. Little bit amount of moisture, particularly in the troposphere part. Troposphere means from sea level to approximately 16 km at equator and 8 km at polar region. So that height, that is called as troposphere, which is consisting of moisture. Moisture is there, then reactivity of metals are more. Again, air is rich of oxygen and metal can undergo reaction with oxygen. Whereas during rainfall, certain acids are formed naturally. It is not human efforts. For example, when thunderstorm, lightning is there, at that time nitrous and nitric oxides are formed. When we are burning out coal, wood, etc., traces of sulfur dioxide are formed, which led into sulfurous and sulfuric acid. And like that, these metals are undergoing chemical reactions. And therefore, we are not able to obtain metal in pure form. In short, metals are rarely found in pure form in nature. For example, gold and iron, to certain extent nickel, but otherwise metals are always formed various compounds, so they are not observed in nature in pure form. Mineral is a substance which is consisting of various elements reacting with each other and forming a stable compound. So minerals are basically compounds from which whatever the components are there, they can be separated, and we are getting various elements. Whereas, say for example, SiO2, silica, is a mineral. From that, we can separate out silicon. So silicon is obtained from silica, so silica is called as a mineral. That means common sand, or more precisely, you are aware of quartz. So quartz is purest form of silica, SiO2. Now, what is ore? Ore is a mineral. Keep in mind, ore is a mineral from which one can extract metal commercially. So if you are able to extract metal, then it should not be considered as ore. But if you are able to extract metal in a commercial way, then only that mineral is called as ore. In other words, we can say every mineral is not necessarily ore, but every ore is a mineral. This much we just revised, and now we are going to discuss how metals are obtained from ore. Because from childhood, I am having these questions in mind, that from where we are getting iron, from where we are getting copper, and how our ancestors came to know. By this way, we can extract this type of metal. Now, many people believe that whatever the chemical development is there, that is there outside India, and then that metals came to India. So, for example, if you are going to IVC, Indus Valley Civilization, then they were using copper. So, it was believed at that time that copper is obtained from Gulf countries. But the thing is that our ancestors were having very good knowledge about these metals, and particularly if you are going through certain shlok, say for example Rudra is name of shlok, where Chamak is category of that shlok. So Cha Me, like that they are having ending. So in English, I can translate Cha as and Me means give it to me. So Cha Me means and give it to me. But what we demanded with Lord Shiva, the shlokas are there like that. Trapum Chame, Sisam Chame, Loham Chame. What is the meaning of that? Trapu means zinc. So and give me zinc. Sisam Chame and give me lead. Loham Chame and give me iron. And like that records are there. Whereas Ayurveda consisting of various metals. You are aware of the thing Makara Dhwaj is name of medicine that is obtained from amalgam. Amalgam means actually alloy of mercury. So Makara Dhwaj is basically alloy, we can say, or mixture of sulfur and mercury. And surprisingly, at that time sulfur and mercury both were not found in India. But medicine is used in India, that is called as Makara Dhwaj. Now these metals, how we are getting metals from ore? The process we are going to discuss. The first step, that is purification of ore. God has given us many things, but not spoon feeding. We have to find, we have to search. So for example, if I want to extract sodium, then sodium is not given, but in the seawater, lot of salt is there. So first thing I want to isolate common salt, that is NaCl, from water. So this process we are calling as purification of ore. So first stage, that is purification of ore. Now various ores are there. I am taking certain names. For example, galena. Galena is ore of lead. Just I am speaking out, you can remember. Hematite, that is ore of iron. Magnetite, ore of iron. Bauxite, ore of aluminium. And like that, various ores are there. But you will not get that in pure form. It is mixed in soil. Usually we are extracting from soil. So it is contaminated with humus. It is contaminated with soil and variety of things. So first stage is there. We want to separate out these ores from impurity. I am not saying separate out metal from impurity. I am saying just separation of ore from impurity. Various methods are available. Say for example, many times we can use a washing technique. Usually, exception like aluminium, metals are heavy. So there are oxides, there are sulfates, sulfides, carbonates, all category of these, they are heavy. So by washing with water, we will get that humus. Humus means decayed matter which is present in the soil, that can get away. And heavier portion will remain at bottom. Sometimes we are using a technique that is called as froth flotation technique. I am revising name, froth flotation technique. Let me explain in very simple manner. I am not going in the technical term. I am going to discuss this in very simple manner. You can see here diagram. So first thing, that such diagram, that instrument is there. Now we are adding out contaminated ore over there. Ore, suppose A is name of ore and B is impurity in that. I have to add certain oil. Oil is going to wet only A, that means ore, but B will not get affinity towards oil. So we are mixing out that with oil. We have to mix it and then we have to add water. Now at central part you are seeing stirrer. From that we are stirring out constantly and air is blown. So oil plus water, you are aware, that is giving emulsion. In emulsion, if we are mixing out air, then obvious thing is that a froth formation is there, that we are calling foam. And oil is forming foam. So ore particles are attached to foam. They are coming out, and now we can say that there is sliding part. From that, ore particles are sliding out with foam and impurities are remaining in the liquid. Maybe possible process is reverse way also. Say for example, ore is not sticking to oil, but impurities are sticking to oil. Then by froth method, we are removing impurity and ore will be there in the vessel. So like that, we are using froth flotation technique. Sometimes ore is magnetic in nature, especially iron, nickel and cobalt. I am revising, we have to use word Fe-Co-Ni. Fe stands for iron, Co cobalt and Ni nickel. They are ferromagnetic substances. Ferromagnetic means we can convert them into permanent magnet. So they are ferromagnetic substances. As a result, we are getting the mineral having certain magnetic properties. And now as I am showing in the diagram, you will see that belt is rotating out. Magnetic component will stick to belt, whereas non-magnetic component will thrown long distance because of centrifugal force as well as gravitational force. And sticky material will stick to belt, which is magnetic one, and fall down because of only gravitational force. So we can separate out this way. Sometimes we are using gravity separation technique. And by just bubbling out, we can check out that ore particles, the heavy particles are going at back side and lighter particles are going at front side. So like that, various methods are there. They are used for concentration of ore. We are calling this as purification of ore or concentration of ore. But these methods are not always useful. In case, suppose I am talking of aluminium, then these methods are not useful because aluminium is very light metal. It is not having magnetic character, that means ferromagnetic character is not there with aluminium. Then what we can do? So aluminium, when we are extracting out it from bauxite, first little bit washing etc. is there, and then we are using a technique. We are dissolving that entire bauxite ore into sodium hydroxide. Aluminium oxide, basically you are aware of bauxite, which is Al2O3, which is soluble in NaOH, and it will dissolve in NaOH. Now we can filter it out. All impurities will be separated and filtrate will contain sodium aluminate. Now add excess of water. As a result, that sodium aluminate will get hydrolyzed to aluminium hydroxide, AlOH thrice, which is appearing as gelatinous precipitate. Just separate out that from filtration and dry it. On drying, we are getting pure alumina, Al2O3. So we begin with alumina, that is Al2O3, but it is in impurity, and at end we got pure alumina, that is Al2O3. Then we are using another technique. The another ore of aluminium is there, that is called as cryolite. So this alumina is mixed with cryolite, and then we are using melting molten alumina, and we are going to electrolyze to get metal. So I am revising again. First step, that concentration of ore. By various techniques are there. I have discussed only few techniques, and then concentrated ore. Now we have to treat further. We are discussing some of the names of ore. For example, aluminium, as we discussed, extracted from alumina, or bauxite, or even cryolite. So like that, names of ores are there. Ore of iron, that is hematite. Another ore of iron, that is magnetite. Then for copper, chalco or chalcopyrite. Another ore of copper is cuprite. More commonly we are using cuprite. Then zinc, that is obtained from calamine. Lead, that is obtained from galena. Then mercury, that is obtained from cinnabar. So like that, various ores are there for various metals. Now, as we discussed, the ores are in form of either oxides, sulfides, sulfate. There is difference between sulfide and sulfate. So ores are in form of sulfate, ores are in form of sulfide. Many times ores are in form of carbonate. Then they can be chloride, bromide, iodide, like that. So various categories of ore, they are there, and depending upon the category, we are going to get the extraction method. So in our first part we discuss here that what is ore, then how ore is concentrated. Now we are going to discuss how metals can be obtained from ore. So it is not common method for each and everything. Methods differ. We have hematite, that is iron ore, that is Fe2O3. So first step, that we are going to concentrate the ore. Now you are aware it is magnetic ore, so we can use magnetic separator. Even flotation technique can be used, but magnetic separator is used here. Then the concentrated ore, we are mixing out with carbon. Now obviously thing is that pure carbon we can't use here, so we are using coal. Now you are aware there are categories of coal. You are aware of categories of coal, otherwise I am giving here data. Say for example, anthracite is the purest form, or rather I should say richest form of coal. That means it contains maximum amount of carbon. So topmost coal or highest carbon content coal, that is anthracite. then bituminous, lignite, and lastly pit. So like that, categories of coal, they are there. Now if you want still pure carbon, then we have to heat coal in absence of air. If you are heating out coal in absence of air, then we are getting coke. Coke means not that drink, but it is called as coke. So which is containing very good amount of carbon. Now depending upon the availability, we have to use material. So we have to mix hematite, that purified ore, with coke. We are taking now mixture of hematite, that is purified ore. We are mixing out with carbon, and we are adding out usually silica and limestone. So sorry, not silica, limestone. That is limestone means calcium oxide, calcium carbonate, but it is later on converted into calcium oxide. So that we are adding out, we are mixing out, and there is a furnace that is called as blast furnace. You can see here diagram of this blast furnace. You will see that from top the material is discharged. Because of gravity it is going to fall down. But look here that there are blowpipes. From that very hot air is blown. As a result, that coke or coal, whatever is present, that powder, that is going to get oxidized. As a result, temperature will rise. And then Fe2O3 will react with carbon as well as carbon monoxide, and oxygen will go with carbon, forming carbon dioxide, and iron will get separated. Whereas silica residue, always keep in mind, if we are obtaining ore from soil, then it is associated with silica residue. Formula of silica is SiO2. SiO2 is insoluble practically in acid, except hydrofluoric acid, which is very, very costly. We can't use it. But except hydrofluoric acid, silica residue is insoluble. So even if you are using aqua regia means 3 parts of concentrated HCl and 1 part of concentrated nitric acid. So if you are using aqua regia, then also silica residue is insoluble. If you are heating out that in aqua regia, boiling out that in aqua regia, then also silica residue is insoluble. So this silica will combine with calcium oxide, which is obtained from calcium carbonate at that time, and it is forming calcium silicate, that is taken as from bottom we can get separate calcium silicate. Then we are getting this iron in form of molten form. This is wrought iron. In Indian language we are calling it as bead. That means that is having very good amount of carbon, because already we have mixed carbon with it, and it is not pure form of iron, but we obtain this way from ore to metal. The next stage, that is from this wrought iron, we have to get pure iron. For that process, the process is there that is called as electro refining. So we have to dissolve this iron into substances, say for example sulfuric acid. It will form ferrous sulfate solution. Now carry out electrolysis. You will get iron deposited. Usually electrolysis process will give 99.99% pure metal. This way we are getting pure iron. Useless. It is called as soft iron. It is not used for making tools, anything. In physics, it is having very good application. So for example, when we are using dynamo, when we have to generate electricity, or we want to use a motor, electric motor, in that this soft iron is required. But otherwise, for making tools, this iron is not useful. So we have to add adequate amount of carbon. The process when we are mixing out one metal with other metal or one metal with metalloid, one metal with non-metal, usually we call it as alloy. So here the mixture or alloy, that is a little bit carbon and iron, is giving very good hardness to this iron. We are calling this as steel. It is not stainless steel what we are using utensils. They are different. Here we are calling this as steel. Steel is having desired hardness. So whatever you are using weapons, sword or knife or whatever the metals you are using, we are saying it is made up of iron. So it is not made up of iron. It is made up of steel. So steel is containing little bit amount of carbon. So this is alloy of iron. In in this steel, another property is there that is called as annealing of that steel. What is meaning of annealing? That we have to heat iron or whatever this alloy steel, we have to heat it high temperature and cool down at different stages. Don't cool out immediately. Cool out at, suppose you are heating out till 800 degrees Celsius. Then keep it sometime for 700, then for 600. I am giving example. And this way we are cooling out at different temperature. The process is called as annealing. With annealing, we are getting desired hardness, elasticity, softness, whatever the properties that can be obtained on this type of annealing process. Indians were very good in this type of technique, particularly the blacksmiths from Andhra Pradesh in ancient period. They were very good in this type of technique. What the swords made up of this type of steel, that is by annealing, it was having a bluish tinge. I am not saying blue color sword, but if you check out like that, tilting out, it is showing some bluish tinge. The sword was very, very hard. Okay, nice thing. This is our knowledge. Who used this? Arabs. Because they imported this sword at very high cost and they prepared their entire empire, that called as Arabic Empire. And finally, Arab invaded Indian parts also. Today they are in Pakistan, but they tried to invade Maharashtra also, because first attack of Arabs were there on Maharashtra, then on Gujarat, and then on Sindh. But swords were made in India at that time, and Indian knowledge of alloy is very good. The best example today also you can check out, that is there in Delhi. Near Delhi there is a place that is called as Mehroli, where we are getting the pillar, not Qutub Minar, but just in front of Qutub Minar this iron pillar is there, that is called as Vishnu Stambha. That is there in the ground. No doubt Delhi is receiving very comparatively less rainfall, but climate of Delhi is drastic. During summer it's very hot and during winter it's very cold. But yet that pillar is not rusted. It is standing as it is, very little bit rusting. Now it is started, but fantastic pillar. So that indicates Indian knowledge about this alloy. Even what is the peculiarity of this Vishnu Stambha? That its expansion coefficient is very less, or I should say linear expansivity. Means what? Suppose you have a strip of metal, you are heating it, then it is going to expand. So suppose I am rising temperature of that metal by 1 degree Celsius. Then what is the increase in length? That is called as linear expansivity. So that is for Vishnu Stambha is very, very, very less. So on heating also it is not going to expand, and on cooling it is not going to contract. It is not a case like Eiffel Tower, that during summer season, in afternoon its height is very high, and during winter season at night its height is low. Little bit. Don't consider that at night it is very small and at morning it is very high, but little bit. So these type of things are there. So our ancestors were having very good knowledge about this part, and no doubt we were using this iron. Now certain people are there, they are saying that during Magad Empire, very unfortunate, but they were not able to extract very good amount of iron. What today we are obtaining from that mine, that even that whatever the remains, it is having very good amount of iron. So our ancestors were not able to extract iron to that extent. But keep in mind Magadha Empire, etc., that is 2300 years ago. Anyway, so this is the process. So how metals are obtained? So we discussed the first stage, that is first we have to define ore, then we have to concentrate ore. After concentration of ore, we are getting the purification process. Usually we are calling this process as reduction. What is the meaning of reduction? So here, technically speaking, we have Fe2O3. So it's heavy. But now oxygen is removed from that and remaining thing is only iron. So it gets reduced. That's why the term reduction is used. Okay, now chemical definition of reduction is totally different. But this is the origin why we are calling this process as reduction. So reduction can be chemical reduction, or if you are talking about bauxite, then that can be extracted by electrolysis process also. So not everywhere we are using this. Sometimes we are using roasting. Sometimes we are using mixed technique. Now for example zinc. Zinc is extracted. First zinc is converted into zinc sulfate. And then zinc sulfate is treated to form zinc, which is impure zinc. We are getting sheets of zinc. That is called as spelter. The spelter is again dissolved in sulfuric acid and then electrorefining is carried out. So like that various processes are there, and in these processes metals are extracted from ore. So this is just introductory lecture. In next lecture we are going to discuss stepwise.